In this lecture, we will continue our discussion on polymorphism. We're going to start by looking at an example that involves bank accounts. Now, there are several different types of bank accounts out there. We have savings accounts, there are checking accounts, certificates of deposits, money markets, all sorts of different accounts to attract customers as well as to meet the specific needs. So what we're going to do in this example is we're going to illustrate how to use abstract classes and polymorphism to process these different kinds of bank accounts. Now, for our example, we're going to look at some of the more common accounts, which are checking accounts and savings accounts. If you're following in the book, you'll see that there's an additional account for certificate of deposit, and that the checking accounts and savings accounts have additional counts with it based on different types of rules and features. We're not going to worry about that in this example. We're just going to have our typical bank accounts, and then we're going to have a checking account and a savings account. And what we're going to see here is that we can create an abstract class, so that's going to be our bank account, and then we can create subclasses based on the type of account. So we'll have one subclass for the checking account, and then we'll have a subclass for the savings account. So not only will these subclasses inherit everything from the bank account class, but they're going to include the additional methods and variables and other features that cater to the checking account and savings account. We'll start with the bank account abstract class. Now I'm just going to mention here that I'm only going to list the variable names and the method names here. We're not going to worry about the complete definitions of all these methods. We're just looking at what information and what methods or operations we should include in this abstract class. And everything that we put in here will be passed down to the checking and savings accounts. So every bank account does have an account number, the name of the owner, and a balance. So we do need instance variables of that. So we would have an instance variable for the account number, the name of the person, and then the balance. So all that's going to be declared in here. Now there are some operations that are common to all types of accounts. So we should be able to get the owner's name, the account number, the account balance, make deposits, withdraw money, and create a monthly statement. So we have some of that stuff. But we need first our constructor. So here's a constructor that passes some parameters, and then we can get the account number, we can get the name of the person, we can get the balance, and then we should be able to set the name of the account. We should be able to withdraw, so that public void withdrawal. We should be able to deposit money in the account, and then we should be able to create a statement. And notice that this particular method is an abstract method because we have the abstract word here. So this is one where if we were to actually define this class, this method would not be defined, but in our subclasses, they would be defined there. And then, of course, we should have a toString method in here. Just that way we can display the appropriate information about the class as a string. We'll next take a look at the checking account class. Now, a checking account is a bank account, so it does inherit all the properties of a bank account. So it's going to inherit all of the attributes, all of the methods from the bank account abstract class. So what this means is, well, we first should have a constructor for the subclass. So we create a constructor that's going to pass the account, the name, it's going to pass the balance. So we get all that information. Now, one of the objectives of a checking account is to be able to write checks. So we do include a method for writing the checks. So we'll pass a value and write the certain amount of check, and it takes care of that. So we need to have that feature in this account. And since the abstract class contained an abstract method for creating a statement, we need to have a definition for the create statement method in here. So we need to decide how we're going to write up a statement for a checking account. And finally, we should have our own version of the toString method in here so we can print out all the contents of the checking account as we see fit. We'll now take a look at the savings account. Once again, it is a bank account. Therefore, it's going to inherit all the properties of a bank account. So it's going to bring in everything from the bank account abstract class. Now, furthermore, a savings account also pays interest. So that means that we need to include some additional data and operations pertaining to the interest. So we should have a variable that stores the interest rate for the account. We do need constructors for this class as well, so we can have one type of constructor that brings in stuff just from the abstract class. So this would be a constructor without the interest rate, and we can have another constructor that does include the interest rate. And then we need some operations for the interest rate. So we should be able to get what the current interest rate is. We should be able to change the interest rate if that does change. We should be able to post the interest rate, so we should be able to display it. And then of course, since the create statement was an abstract method in the bank account class, we do need to define it in here as well. And then of course, we'll include a definition of the toString method. So we have all these different types of accounts. So how do we actually handle creating them? Well, we could just create a reference variable for each type, but that seems like it would be pretty tedious. So what we can do if we want to create various types of accounts is we'll take advantage of vectors. So if you remember from CS121 that a vector is very similar to an array, the only difference is the vector object can actually increase in size if we need to add additional things. So there were methods that allow us to create a new element of the vector, and then we can add stuff to it. So what we can do in this particular case is we can create a vector, and this vector should have all the different accounts, and if we need to create a new account, we'll just add a new element to the vector. So what we're going to have here is the elements of this vector object will be of type bank account. So this is where we can take advantage of polymorphism. So all the elements of this vector will be of type bank account, but because of the rules of polymorphism, we can actually instantiate objects of the savings account and the checking account for each of the elements in this vector. So while the vector is technically a vector bank account, each element can be a checking account or a savings account. So let's take a look at a very simple example. So here I create a vector, and the type is going to be the bank account class. So I'm allowed to do that. And then we'll call this accounts list, and then we would create a new object of the vector class. So this is going to be a new vector of bank accounts. Initially, there aren't any accounts in here. There aren't any elements, but we can use methods for adding elements to this. So now we can create as many accounts as we want. Now that we have our vector of bank accounts created, we can add elements to it. So these first two lines will add a savings account and a checking account. So this first line, accounts list.add, and then in the parentheses, we would pass an object of the savings account. And notice that inside of here, I didn't include any reference variables to an object of the savings account. I just put in the object directly. So we have this new savings account, and then we pass the arguments for the constructor. This is perfectly legal. We're not required to create a reference variable, then create the object, store it in the reference variable, and then pass the reference variable. I can just put in the new object directly as a parameter for the add method. So this is perfectly fine the way we're doing this. And then the next line, we would add a checking account. So we would create a checking account object. In this case, we have a guy by the name of John, and he has an account number of 12357, and he has $3,500. So we have that checking account object, and then we add that as a new element into our vector. And we can continue with that if we want. And then we can call all of the different methods associated with one account or the other. So for example, we have accounts list dot element at one dot withdraw 500, which means that we are going to withdraw $500 from the checking account, because element at one, that's saying get the element at index 1 technically. So if we follow this order, that would be the checking account, and then we're going to withdraw $500 from that. And then we also see here that we can use a for each loop to do stuff with each element in the vector. So in this case, we can create a statement for each account in here. So we have for bank account, accounts list. So account is going to store the object for that particular element in the vector. And then we're going to invoke the create statement method, which we can do because for both the checking account and savings account, the create statement method is defined, and then we can print out the contents of the account because the toString method is defined in both of those classes as well.